All right. So like I said, a lot of your definitions were really good. Parallel lines are two lines that aren't going to intersect. Perpendicular, they intersect to make a right angle. And so we're going to talk about slopes of those lines. So remember, slope measures steepness, how steep the line is. And so if we have a parallel line, well, that means they're never going to meet. And so hopefully it should make sense that the slopes of parallel lines are going to be the same. Because if we have two lines that never intersect like this, if we have two lines that aren't going to cross, then it should make sense that their steepness is going to be the same. Because if one of them is steeper than the other, then it's going to catch up to the other line, either on this end going out this way or on the other end going out this way. So for them to keep at the same pace with each other, we need their slopes, their steepness to be the same. The rule for perpendicular, making right angles, the rule for perpendicular is that the slopes are opposite reciprocals. What I mean by opposite reciprocal is that we're going to change our sign, and reciprocal means that we flip the fraction. So opposite means we change the sign, and reciprocal means we flip the fraction. So for example, if we want the opposite reciprocal of 2/3, 2/3 is going to become opposite reciprocal. Well, we're going to change our sign so that positive is going to become a negative. And then reciprocal, we flip it and becomes 3/2. If we want the opposite reciprocal of -7/4, I'm just using some examples here, just picking some numbers. Opposite reciprocal of -7/4, we're going to change our sign. So negative is going to become a positive. And then flip our fraction 4/7. If I want the opposite reciprocal of 3, well, that would be 3/1. So when I change my sign, it's going to be negative. When I flip my fraction, 3/1 is going to flip to be 1/3. So that's how we create opposite reciprocals. So let's talk about how we're going to solve these. We're going to have a kind of step-by-step process here. Step 1, we're going to get our new slope. So if it's a parallel line, if we want it to be parallel, then that's going to be easy. We're going to make it the same slope as we had before. If it's perpendicular, we're going to do this process that we just did to find the opposite reciprocal. Step 2, we're going to use that in our point to get point slope form, which I'll talk about in just a second. And then step 3, we're going to solve for y. And so let me talk about this new form. Point slope form is just going to be an easier way for us to come up with an equation on these problems. It's actually taken from the slope formula, which, if you remember, is change in y over change in x. It comes from this formula. So some of this we talked about at the very beginning of the year when we talked about how to graph lines. So some of this should look familiar to you. So x1 and y1 here, these two are the x and y coordinates of our point. So the point is going to go, the x coordinate of the point is going to go with x1, the y coordinate of the point is going to go with y1. And then m is our slope. We use m to stand for slope. So that's our process here. We're going to get our new slope by determining whether we're looking for a parallel or perpendicular line. We're going to get the point slope form, and then we're going to solve for y. So let's look at an example here. While we're getting set up for the next problem, you need to be, we're going to be looking at it being parallel to the line y equals 2x minus 3. So before we start, I want you to take a minute and graph 2x minus 3. See if you can remember how to graph that equation of y equals 2x minus 3. All right, for y equals 2x minus 3, remember when we're graphing our lines, we want to start at our y-intercept. So this is our y-intercept. And then the 2 is our slope. So if we want to get our y-intercept here, that means our y-intercept is at 0, negative 3. So we're going to be at 0, and then we're going to go down to 1, 2, 3. There's our first point. And then we have a slope of 2. Slope of 2 means we go up 2 and to the right 1. Because up and to the right are positive directions for x and y. So we're going up 1, 2, and to the right 1. Up 2 to the right 1. Up 2 to the right 1. And so on. Or go the other direction, down 2 and to the left 1. So our line, connect our dots here, should look like this. Slope of 2, y-intercept of 0, negative 3. So we started our y-intercept and then count along our slopes. All right. Let's get our other line that we want that is parallel to this line. So step 1, we get our new slope. Well, our new slope is going to be, let's see, it's parallel, so the slope should be the same as my slope from before. So my slope right there was 2, so I'm going to just copy paste it down here. It's still going to be 2. And then the point we're going to use is negative 1, 1. This is going to be our point. So we're going to get out our point slope form. Y minus our y coordinate equals the slope times x minus the x coordinate. All right, y minus our y coordinate of the point. Well, the y coordinate of the point, remember, is the second coordinate in the list. It goes x first, then y. So our y coordinate is 1. Equals our slope. Well, our slope was the same because we're looking at the parallel line. So our slope is still 2 times x minus our x coordinate. Our x coordinate here is negative 1. Negative 1. So that means our point slope form here is y minus 1 equals 2 times x, and then minus the negative is going to be plus 1. So we got our new slope here. There's our point slope form. Now we just need to solve for y to get our new equation of the line. So I'm going to distribute, to solve here, I'm going to distribute the 2. So we're just simplifying on the right side. So 2 times x, that's going to be 2x. And then plus 2 times 1 is going to be 2. And then I have a y minus 1 here, so I want to get y by itself. So all I need to do to get rid of the subtracting is to add 1 to both sides. So when I do that, then I should get y equals 2x plus 3. And there's my final answer for the equation of that line. So y equals 2x plus 3. That means we are going to start at our y-intercept of 3. So 0, 3 is my y-intercept. And then my slope, well, it was the same because it was supposed to be. Slope of 2 means we move up 2 and to the right 1, and up 2 and to the right 1, or down 2 and to the left 1. We're counting our same slope because since it was parallel, the slopes should run the same to each other. Down 2 to the left 1. And so here's our new line. So your graph can kind of be a way, can kind of serve as a way to double check your answer here. Can be a way to double check your answer because it should be parallel, looks parallel to me. You should know what a parallel or perpendicular line looks like. So do they look like they're never going to cross, or do they look like they're going to make right angles? That's number 1. And number 2, does it go through the point that it's supposed to? So it's supposed to go through negative 1, 1. So I look, negative 1, 1. There it is. It goes through the point that it's supposed to. So that's how we know we did it right. So get our new slope, which was the same. Put it in your point slope form. Solve it for y. Distribute, move this to the other side. All right. So I'm going to jump down to this one because it's a perpendicular one, and I want to look at a perpendicular one. Same steps. The only thing that's going to be different is this first step of getting the new slope. So our line that we're looking at is y equals negative 2x plus 2. So I'm going to go ahead and graph that. Our y-intercept this time is at positive 2, so we're going to go up to 2. And then our slope is negative 2, which means we want to move down 2 and to the right 1. Down 2 and to the right 1. Right? Negative slope means we should be moving down from left to right. Or up 2 to the left 1, up to the left 1. So remember that this time we want something that runs perpendicular. So when we get our new slope, we're going based off of negative 2. Negative 2 is our old slope. This time, since we want perpendicular, it's going to be the opposite reciprocal. We're going to change our sign. So the negative is going to be a positive. And then we're going to flip our fraction. Well, this was negative 2 over 1. Talked about that before. Negative 2 over 1. And so when I flip my fraction, it's going to be a positive 1 over 2. So 1/2 is going to be my new slope. So I've got my slope. I've got my point, which is a 2, 3. So now we can get our equation. Y minus the y coordinate equals the slope times x minus the x coordinate. If I want y minus the y coordinate, that's going to be 3 is the second coordinate here. Equals our slope. Well, our new slope that we want here is a positive 1/2. That's what we got from our opposite reciprocal. And then times x minus the x coordinate. The x coordinate here is that first point listed, it's 2. So that's going to be our point slope form. So now all we need to do is solve for y. I'm going to go ahead and distribute the 1/2. So I have 1/2 times x. And then I have half of 2 is 1. So again, I have a y minus 3. I want to get y by itself, so all I need to do to get rid of that subtracting of 3 is to add 3 to both sides. And so we have 1/2 x. So negative 1, I've got plus 3. Negative 1 plus 3 is going to be a positive 2. So our new line is actually going to start at the same place. It's going to start with a y-intercept of 2. And then our slope of 1/2 means that we are going to move both positive directions. So we're going to move up 1 and to the right 2. Remember, this is change in y over change in x. So the top of 1 means we're moving up 1. Bottom being positive 2 means we're moving to the right 2. That's our positive direction for x. Up 1 to the right 2. Up 1 to the right 2. Or we're moving down 1 to the left 2. Down 1 and to the left 2. Down 1 and to the left 2. So our line should look something like this. Again, your graph should be a way to check your answer. So we're looking for, they should be perpendicular. So that means that I should be able to draw a box here to say this is a right angle and not look completely nuts. Well, that looks reasonable. And then the other thing I want to check, other than perpendicular, is that it goes through our point, 2, 3. Let's look for 2, 3. 1, 2, up to 1, 2, 3. Bingo! We have it. So we do go through the point 2, 3. So to recap one more time, we're going to get our new slope. If it's parallel, then the slope's just going to be the same. If it's perpendicular, then they're going to intersect to make right angles. If it's perpendicular, that means we're going to have opposite reciprocal. Opposite change your sign, reciprocal flip the fraction. Then write your equation in the point slope form and solve for y. Distribute, move this part to the other side. So those are our steps for doing these problems.